In this lesson, we'll be focusing on Theorem 1 of Euclidean geometry. So it says, a line from center, perpendicular to the chord, bisect the chord. So there are three terms which we can see there: perpendicular, chord, and bisect. Now, the word perpendicular means 90 degrees. If they say line AB is perpendicular to line BC, it means that AB and BC forms an angle of 90 degrees between them. And a chord, we said, is a line that joins two interior parts of a circle but not passing through the center. So look at line AB. It joins two interior parts but doesn't pass through the center. And to bisect is to cut into equal halves. If I've got this line and then I cut it into equal halves such that this line is equal to this part, we say it is bisected. Is to cut into equal halves. I hope it's clear. So suppose here we've got E. They say we must prove that indeed a line from center, which is OF. Okay, what they are saying is that OF is perpendicular to AB, is what is given, right? Is the given statement. Then they say to you, prove that what they are saying there is true. So prove that if OF is indeed perpendicular to AB, therefore OF will cut AB in two parts which are equal. So we must prove that AB is equal to FB. Well, can we do that? Yes, we can. The way in which we prove this thing is by using congruence. Whenever you are proving a theorem, you must have construction lines. If you don't construct, they don't give you marks. So we're going to construct two hypotenuse. We're going to construct two hypotenuse lines, hypotenuse AO as well as hypotenuse. Let's do this. Okay, the line there is giving me an issue. Let me just construct with my pen there. Okay, so remember, we must make a line, join AO as well as OB. That's the first step, and that's a mark for constructing, right? So what we're going to do here, we're going to prove congruence. Remember, we have said that two radiuses of a circle are the same everywhere. So this means that we're going to prove congruency, and we can prove congruency in, was it 3 or 4 ways? Let's look at those ways. You can prove side, angle, side, that two sides of this triangle and two sides of the other triangle are the same, and the angle between them. What we mean is this way. If two lines here and the angle in between the lines are the same as two lines of the other triangle and the angle between them as well, we say these two triangles are congruent. This means they are symmetrical, they are equal, such that if triangle A is placed on top of triangle B, it will leave no space. We say they are symmetrical. Therefore, we say it's side, angle, side. Two sides of this triangle and the angle between them are the same as two sides of the other triangle and the angle between them as well. I hope it is clear. So now let's look at the second condition. The second condition that we prove is, we said the first one was side, angle, side, right? So the other one will be side, side, side. So you know these things, guys. It's just a recap. I'm not supposed to be doing this, but it's side, side, side. Side, side, side means that three sides of this triangle are the same as three sides of the other triangle. Therefore, we can say triangle A and triangle B are congruent, and the reason will be SSS. If you want to write the full abbreviation for it, well, you can feel free to do so. But if you want to write them in full, you can. If you want to shorten them, you can. It's also accepted. So the other one is angle, angle, side. So the other is angle, angle, side. Angle, angle, side simply means what? Obviously, it's an angle, it's an angle, it's a side, right? And then it's an angle, it's an angle, then there's a side. Therefore, these two are congruent. And then there's the last one. The last one includes the hypotenuse. Let's take a look at it. So, the last one is RHS. RHS is what we're going to prove in this theorem. It's a right angle, which is the 90-degree angle, the hypotenuse, which is the longest side of the triangle, and the side, which we are proving to be equal, right? So, we're going to prove that if this angle here, if this triangle, this one have got a 90 degrees, a hypotenuse, and a side, and the other one has got a 90 degrees, a hypotenuse, and a side, and these are equal. The side in here is equal to the side in here, the hypotenuse in here is the same as the hypotenuse in there, and similarly the angle here, the right angle, and the one here are equal. Therefore, we say two triangles are congruent, and the reason is RHS, the right angle, hypotenuse, and the side. If you feel like you want to write it in full, feel free to do so. So we're going to prove, right? So what we can form here is, we know that AO and OB are two radiuses. So we can say that the two radiuses are equal. AO and OB are equal. And because here is 90 degrees, even here is going to be 90 because of sum of angles in here on a straight line are supplementary, right? So we're going to prove this. Let's start. We can say that AO, okay, let's write in which two triangles are we proving. We say that in triangle AOF and triangle OFB, order doesn't matter in congruency, but matters in similarity. So we can say that side OA is equal to side OB, and what makes us say that is the radii or the radius. But I prefer you write radius because it's the one that is written in the exams. So it's a reason, right? Then again we can say that OF is equal to OF. Why? It's because it's a common side. Alright? So the side is common to both triangles, therefore it's one side. So we can say it's equal. And then the other side, which one will it be? Is it the side? No. Now we're talking about the angle, the 90-degree angle. It's AFO. We show F with a cap between to show that the angle is on F is equal to BFO. This means that this angle right here, the angle here, the 90 degree in this triangle, is equal to the angle, the 90 degree in the other triangle, right? And therefore, what is the reason? Well, the reason is given. What can we say there? Give me a reason. Here is 90 degrees and there is 90 degrees as well. So what we can say is that they are both 90 degrees. Or if there's another reason which you can give, feel free to plug in the comment section. So we have done it, right? So there it is. We have done it. So if you want to, guys, you can say that sum of angles on a straight line, right? Some of your teachers will tell you that the reason here, you can also say the sum of angles on a straight line. So feel free to use that reason as well. I don't think they'll penalize you for doing that. Okay, so this is line here. And then because we have proved this condition, the hypotenuse of this triangle and the hypotenuse of the other triangle, the 90 degree and the 90 degree, the side and the side, we can say that therefore triangle AOF is congruent to triangle OFB, and the reason is RHS. The right angle of the other triangle, which is the 90 degrees, is the same as the right angle of the other triangle, and the hypotenuse of the other triangle is the same as the hypotenuse of the other, as well as the side. Therefore, we can conclude that that is congruent. The symbol here stands for congruent. Don't confuse it with 3 ones which are like this. This stands for similarity, and we will do them when we are doing the equiangular angles. But for now, don't focus on the similarity. Make sure you're able to prove this theorem. By the way, it's for exam purpose. So therefore, it's not complete. We can say that therefore, because you are saying that the two triangles are congruent, it means that AF is equal to FB. And what is the reason? The reason is by congruence. Okay, let me illustrate that. Suppose you are given triangles, right? And they tell you that the triangles are the same. There are two triangles. We'll just say they're the same. If here it's 5 and here it's 4 and here it's 5 and here it's 4. Guys, what does this mean? It means that here it's 5, here it's 4. Here it's 5, here it's 4. It's obvious that the two triangles are congruent. Alright? Therefore, we can conclude that even these ones here are the same. That's why we say that by congruence. So by proving congruency, we can see that we've got a right angle, hypotenuse, and the side, So we can say that by RHS, we can conclude that x2 is equal to x3 here. This means that the x in there is the same as the x in the other triangle. I hope it is clear. So that is why we said, therefore, AF is equal to FB. Because AO is the same as OB and OF is the same as OF. It means the triangles are the same. We said they are congruent, meaning they lie on top of each other. Therefore, we can simply conclude that AF is also equal to FB. I hope it is clear to everyone. So, Euclidean geometry is one of the easiest sections which you will score full marks from it. Just have a positive attitude and a mindset to it, and all will go well with you. I hope it is clear. So feel free to rewatch the video as many times as you can until you understand. Don't skip a section without fully understanding it. Thank you for watching.